Hello everyone and welcome to Lukma No Hands Multimodal AI Agents in the browser. As you can see, my talk title follows a very simple structure. I have a catchy main title, which is then followed by some interesting buzzwords in the hopes that people would actually show up. But it also means that I will spend the next half an hour talking about those three buzzwords. So first of all, we will look into why and how we can use machine learning in the browser. Then we will talk about AI agents, and last but not least about multimodality. Okay, now whenever I think about AI agents, I think about something like Jarvis. So Jarvis is the AI assistant of Tony Stark in Iron Man. And the idea behind Jarvis is that it is this AI assistant that knows everything, it can do everything, and it's basically the perfect assistant for Tony Stark. So I thought to myself, how hard could it be to build Jarvis, but in the browser? Why in the browser? We heard that already twice. Everything that can be written in JavaScript will be written in JavaScript, and I wanted to see if I can do that in JavaScript. Let's find out together. I have Jarvis here, and I can now ask it. Hey Jarvis.
Good morning, Nico. How may I be of assistance today?
Do I have any appointments today?
You have one entry on your calendar for today, Nico, the Nordic.js conference, which is listed as an all-day event. Do you require any further details regarding this or any other matter?
Okay. Now, all you've seen is happening directly in the browser. Now, how does that work under the hood? Before we dive into that, a quick words about myself. As you've heard before, my name is Nico. I am from Switzerland. I'm a machine learning engineer at Hugging Face, and as you've heard before, that's actually my second day at Hugging Face. So I started yesterday on October 1st. But at Hugging Face, I am working on a library that I used quite heavily in the last couple of months and years, and which is also the core that powers everything you see in Jarvis, and that is Transformers.js. So Transformers.js was released in 2021 by my colleague Joshua Lochner. He is better known by his handle Zenova. He then joined Hugging Face in 2023, so the whole library is now part of the Hugging Face family. And the whole idea behind it is to make it as easy as possible for you as JavaScript developers to run machine learning models directly in the browser, or also in Node.js or any other JavaScript runtime. So it's actually runtime agnostic. Now the way it works is that we have around 155 popular model architectures across 27 tasks. That means there are around 1,850 ready-to-use machine learning models that you can just use in your JavaScript application. The way it works is most of the stuff you can just do with this pipeline, so you can import the pipeline function from Transformers.js. You can then define a task. In my case, for this example, I want to have sentiment analysis. If you want to, you can also define the model. So here I want the BERT-based multilingual model. Now when this code runs, it will download all the required files from the Hugging Face Hub into the application storage. So you can use this progress callback to show the progress. Next time it runs, it will take that from the application storage. So it's actually quite fast the second time. And how long it will take to download those really depends on the models. Some models are just a couple of megabytes, which is pretty fast. Some can be a couple of gigabytes. So you need to be cautious there. You can also set a device, so you can define where those calculations should run. The most performant way to run machine learning operations in the browser right now is WebGPU. WebGPU is a browser API that is supported by all major browsers by now. It's in Safari. I think it's in the beta version of Safari 26, but it has cross-browser support. And what we can do then is you can basically take any input. In my case, I have a sentence, I love Transformers.js. It will take that input, run it through the model, and it will then return the output. So I have now an array of labels. So in that case, it is 99.9% sure that it is a positive sentiment. Okay, Just one quick thing, I have no idea about the timing because I don't see the timer on my screen, but yeah, it will work. So we now know that we can actually run machine learning models directly in the browser. Now let's talk about AI agents. So what is an AI agent? A very high-level overview, an AI agent is a program that autonomously completes tasks or makes decisions based on data. At the core, an agent needs a large language model, an LLM. And I think we all use LLMs by now. An LLM is just a machine learning model that takes some text as an input and will then generate new text based on that input. And there are quite a lot of models. Most of us use models in the upper left corner. That would be GPT-5, GPT-4, Claude, Gemini. Now those are big closed models. Closed means that they were trained by Google, Anthropic, OpenAI, and then you can use them through the API, through the text interface, but you are not allowed to or you can't use them in your own systems. Then there also are open weights models. Open weight means that the trained weights and also the architecture is open source, so you can use them in your own systems. The thing here, those models are really, really big. I would call them giga LLMs. The size of a model is determined by the amount of parameters, the amount of weights we have between the neurons. And with those models, we're talking about weights up until 2, 3, 4 trillion parameters. The bigger a model, the more processing power we need to calculate the next tokens. So those really don't work, really only work in specialized infrastructure. Then we have smaller models, jumbo LLMs. There we have models from 27 billion parameters, 30 billion parameters. And there we also have a new category of models, and those are open source models. And the difference between open source and open weights is that an open source model, not only the weights and the architecture, but also the whole training data and the training process is open source. So we know exactly what those models were trained on. There's one example that is the Apertus model. It is actually a Swiss LLM, and it's a joint effort of some Swiss universities and also the Alps supercomputer. So it is an open source LLM that is available on the Hugging Face Hub that you can use. And then there are tiny LLMs. And tiny LLMs are LLMs that are so small that we can actually run them on our smartphones or also on our laptops. There we have the Gemma family from 270 million parameter. Remember, the GPT-5, there are like more than 3 trillion parameters. So we have 270 million parameters. We have the Qwen3 that I used quite a lot also for Jarvis. We have small LM3, which is trained by Hugging Face, which is also open source. And we have a small version of the Apertus model. Now, there are quite a lot of models, but that's not at all the models. If you are interested in that, on the Hugging Face Hub, you can filter by the task text generation, and there you will find around 300,000 different large language models that are available on the Hugging Face Hub. Okay, now we have the models that are small enough that we can use them on device. Let's see how we can use them in Transformers.js. It's pretty simple. We have the task text generation. Now I want to use the Gemma 3 270 million parameter model. Again, it's a super small model. And all I have to do is to pass an array of messages. So I have one system prompt and one user prompt, and I can then wait for the full answer. Let's try that out. I have a system prompt. You are a helpful assistant. Who are you? And if I now click on generate, it will generate the answer. It actually does that really, really fast. And all you've seen is happening directly in the browser on my device. It does that at around 52 tokens per second. Now, there still is a little delay, and that's because I'm not yet streaming. I'm just waiting for the full response to be generated. I can use streaming with this text streamer. There I have the streamer that I can pass to the pipe method. And now I have this callback function. And this callback function runs whenever a new token is generated. And I can then add that to a response in the end. Let's see the same example here. You are a helpful assistant. Now I wanted to write a poem. A poem could be quite long. So if I now click generating, you can see that it actually adds tokens as they are generated. Again, we have around 200 tokens in around 3.7 seconds with the Gemma 3 270 million parameter model, all happening on device. So we can use LLMs on device in the browser, but the knowledge they have is quite limited. They have knowledge that was trained in the training data. They have knowledge from the system prompt, from the user prompt. But if I want to talk about the events, like all my calendar events, it has no idea about those events. If I want to do that, I need a concept called tool calling. The idea of tool calling is that basically we have an LLM that decides when it's time to call a tool. So we have a list of tools. Most libraries that we can use have native tool calling where we can just pass the array of tools to the function, and it will then figure out when they want to call a tool. But the important thing is that an LLM cannot call a tool. An LLM will never call a tool. All an LLM can do is it can generate a signature or generate some piece of text that will indicate or that will tell the application that, hey, now it's time to call a tool. The application can then call the tool and can then return the response back to the conversation. Now, the thing here is that most of the small LLMs, they don't support tool calling out of the box. Some do, like the small LM3 from Hugging Face, they do support tool calling, but sometimes they don't work very well in small quantizations or if they're compressed really, really high. And then we have specialized tool calling models, but they tend to overuse tool calling. So they will just try to call tools even if they could just answer the question from the context that I have right now. So the solution that I came up with is to just use tool calling from the system prompt. So in my system prompt, I have some instructions, and then I tell it, if you think you need to call a tool, you can do that. I have available tool. I now have the get weather tool, and that's the key point. I also have examples because LLMs, they love to work with examples. So if they have a similar input to one of the examples they already have seen, then they know what to do in that situation. So I have examples, and then I'm also quite strict about the output format. I wanted to generate XML because XML is easy for me to then parse, execute, and get back to the conversation. So what I can do here is, what's the weather in Thun? Thun is by the way, the city where I live in. It's a small city in Switzerland. But it will now generate this XML function call. So now I have the XML that I can use in my application. But the other cool thing is that if it doesn't have to call a tool, it won't. So if I just ask it, who are you? It will just generate an answer right away. Also, one thing you see is I'm not using the Gemma model. I'm here using the Qwen 3 because I figured out that the Qwen 3 is only slightly slower, but it is way better when I want to have this structured output like XML or stuff like that. Okay, now I have tool calling, so I can write my application that has the LLM as the core, and then I have tools that I integrate. The problem is that in this approach, I really have to write each tool myself. I need to write an integration for the Open Weather API, for the File System Access API, so everything is very tightly coupled. A better approach is to use the new Model Context Protocol, and I think some of you might already heard of MCP, and the whole idea behind MCP is that you have a decoupling. So you have the MCP client, which is my AI agent, which is my assistant, and then I only have to write one Model Context Protocol adapter that could then adapt to, in that case, a Open Weather API MCP. So it's this decoupling between I am building an AI agent, I'm good at building AI agents, Someone builds a service and they are good at building tools for their service, and they could build an MCP server for Open Weather API, and I could just use them, in that case, via HTTP. Okay, so we have tool calling. Let's have a look at multimodal LLMs, because right now I was only talking about text in, text out. And that's basically all I can do right now. I have text. That text goes through the LLM, through the agent, and I then have text on the other end. What I wanted to do is I wanted to have audio input that goes through the LLM and then generates audio output. Now, the easiest way to do that in my case was to just use another category of machine learning models, and those are audio transcription models, like Whisper in that case, or on the other end, speech synthesis models, like Kokoro on the other end. And now I have this complete multimodal conversation pipeline. The way we can use Whisper and Kokoro is, again, with Transformers.js, of course. So we have the automatic speech recognition task. I now use the Whisper Tiny, and then I can pass any audio to the transcriber, and it will return the text. On the other end, I am using Kokoro. The Kokoro.js is a library that was written by Joshua, so it is a small abstraction on top of Transformers.js. The API looks very, very similar to Transformers.js. And here I have this tts.generate. It accepts a text. I can also specify a voice, so there's a list of voices that Kokoro can use, and it will then return the audio back. Okay, let's see how that works. I have this little button here, and I can now say, "Good morning, how are you?"
Good morning, I am doing well, thank you for asking. How are you today?
Okay, so as you can see, it does now the full pipeline, audio in, through the LLM, audio out. But there's one little problem. I still have to use my hands because I still have to activate the recorder, and I have to stop the recorder so it triggers the transcriber, LLM, and all of that, and so it triggers the whole pipeline. If I want to get rid of that, I can use, again, another category of machine learning models, and those are voice activity detection models. Voice activity detection models are usually very, very small machine learning models that take a very small bit of audio, and all they do is just return the probability whether they think if there's someone speaking or not. That's all they do. So what I can do here is I can activate that. I can then say something. And what you can see is it recorded now around 4 seconds of audio. It processed, in those 4 seconds, it did process 113 small chunks of audio. Each chunk is around 32 milliseconds of audio. And now to process one chunk, it only takes around 1.3 milliseconds. So it is really, really fast at just saying, yes, that's speech, or yes, that's voice, or no, that's no voice. Okay, now I can also add that to my pipeline. I can now, "Hey, good morning, how are you?"
Good morning, I am doing well, thank you for asking. How are you today? You're welcome, I'm glad I could help. How can I assist you today?
Could you tell me who trained you?
I was trained by the Gemma team at Google DeepMind. Okay, I'm ready. How can I?
Yeah.
Okay, I'm ready. How can I help you today? Okay, I'm ready. How can I help you today?
Now we're good. Okay, so you can see it's actually live, and I didn't know that maybe it's because of the audio input is different than when I tried it at home. But again, it did work, so I can now talk to it, and it knows when I'm speaking, it can transcribe everything, and it can then run that through the model, and on the other end, we have audio back. Okay, so we now have the full pipeline. Let's get back to Jarvis. So the way Jarvis works is I can open the chat here, and I have basically a very big system prompt. And in the system prompt, I have some, I explain it, hey, you are Jarvis, the sophisticated AI system from Iron. I also give it some, I tell it how it should behave. So I give it some core traits, communication style. I can also provide some instructions because stuff that I figured out it did poorly or didn't do well. So I can just say, hey, never use ellipses, never do that, blah, 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 blah. And then I have tool calling. So that's basically the instruction that I wrote for tool calling, and that's the list of all the tools. There is this get calendar entry tool. There are more tools. That's basically how I tell the LLM, if you want to call a tool, that's the exact format that I expect. And now I have the conversation from before. Hey Jarvis, good morning Nico, how are you, blah, blah, blah. Then do I have any appointments today? And now Jarvis realized that, to answer that question, I need to call this tool. It will call the tool, or it will generate the XML to call the tool. It will then the application will then take the XML, it will execute the tool, it will return the response to the conversation. So that is basically the response from the tool call. And now Jarvis can generate a new answer based on the question and the response from the tool call. And that's basically it. Now those tools, they're coming from those MCP settings. As I said before, I tried to decouple everything, so I have some built-in MCP server. So MCP is just the standard. MCP expects JSON to be sent from the client to the server, and it expects a similar structure to be sent from the server back to the client. So I am able to write built-in MCP servers that are just JavaScript. I also have a remote MCP server, HTTP MCP server, like this Google Calendar MCP server, where it triggers, so it does a post request to the server and then gets the answer back from this post request. And I'm also able to write my own MCP servers, like I tried to solve one of the biggest problems that LLMs have right now, because they are just not funny. If you ask an LLM to write a joke, they will make up some garbage joke. So I created an MCP server that would trigger the jokes API. There is a jokes API that has a lot of jokes. And I just wrote this one server that it could then trigger. So if we go back to the chat, hey, could you tell me a funny joke about programming?
Here is a joke for you. The generation of random numbers is too important to be left to chance. Is there anything else I can assist you with?
I don't really get that. Could you explain that to me?
That is a subtle piece of programming wit, Nico. The humor lies in the technical irony. In computing, truly random numbers are difficult to achieve. We rely on pseudo-random number generators, or PRNGs, which are complex deterministic algorithms designed to produce sequences that appear random. The joke plays on the fact that because these random numbers are crucial for simulations, security, and other applications, the process of generating them is met.
Okay. Cool. So I didn't solve the problem of not being funny fully, but it's a step in the right direction, I would say. Okay. Let's have a look at the last part of my presentation, because right now my Jarvis can process audio, but what about images? Now there are specialized models that can actually work with images, and those are vision language models. So as you can see here, I have an image on the left, I have text on the right, and now I want to have an image that combines those two. The thing is, an image is not the same structure, data, whatever, as text. But what we can do is we can use embeddings to create a shared vector space. So an embedding is basically just a real-world representation of the semantics between an image and text. So I have a shared semantic vector space. That means I now have vectors that represent the image, I have vectors that represent the text, and I'm now able to train a model that combines those two. Or it's not actually me who does the training, because there are people that are way smarter than I who do that. So We have, for example, one at Hugging Face, the small VLM. It's a super small vision language model that was built to run on device, so it's very small in size. It is super efficient to run, and we can also use it with Transformers.js. Unfortunately, we don't have a pipeline a task yet, so it's a bit tricky to get it working, but we can actually do that. And what I can show you now is I can take an image, I can ask what is on the picture, and it will now answer the question. There is a bridge in the picture, okay. But the cool thing about vision language models, again, they combine the text and the image. So it's not just taking an image and writing a description about the image. If I'm more specific, I want to ask it, what's the color of the bus? It will now look at the image and it will find the bus on the image and it will tell me, yes, the bus is red. So I have not that much output that answers my question. Okay, let's see how we can add vision language models to Jarvis. So what I did is I have this one MCP server that tries to take a picture and will then answer the question based on the picture. So if I now ask, hey, could you tell me the color of the shirt I'm wearing right now?
Certainly, Nico. I shall take a quick visual scan to determine the color of your shirt. Primary issue with pseudo-random number generators, Nico, is their deterministic nature. Since they rely on a fixed algorithm and initial seed value, a sequence of numbers is entirely predictable if the seed is known. This predictability is a significant vulnerability, particularly in cryptographic applications.
Yeah, whatever. But if we go, thank you. I think it somehow got stuck here because the picture was taken successful. Description: the user, what's the color of the shirt? Assistant: the user is wearing a gray T-shirt, and that's fine. I have no idea why it tried to generate this. Yeah, AI LLMs are unpredictable. Okay. Now, to end my talk, I have 3 key takeaways that you can take home from that talk. First of all, the browser can do way more than you think. Unfortunately, I have seen a lot of developers, all kinds of developers, that look at the browser as this one thing where they can just display the, or they have a visual display of the whole application logic that happens in some servers. But that's not true. The browser can do so much things. We have WebAssembly, where we can have complex machine learning architectures that we can run in WebAssembly that would then talk to WebGPU, so we can run really complex mathematical operations through JavaScript directly on the GPU, and that is pretty amazing. Also, you don't always have to use the biggest models, and I get it. There is a new model. The bigger the models are, usually the better they are. There's Claude Sonnet 4.5 came out a couple of days ago. It's an amazing model and it's super fun to use them. But if you are working with an LLM as a tool in your tool chain, if you have an agentic setup, you don't need to use the biggest tools. You can use small models for specific tasks. I have one model as an LLM. I have one model for text audio transcription. I have one model for vision language combinations. So I have small models that work in this agentic setup. And that's not only my opinion. There's also a great article by NVIDIA where they dove into that subject that you can use those small large language models in your agentic setup. And last but not least, we are front-end developers. We have this amazing superpower that we can just build the applications that we want in the browser. We have all the tools available just in the browser. When I started building websites, I was around 13, 14 years old. And I didn't have to write software. I just wanted to see what is possible in the browser. So I tried to write some HTML, tried to write some CSS, tried to write some JavaScript. And there's so many tools that are just in the browser that are available to us. And now with AI, with machine learning, with large language models, we have one more tool that is in the toolbox, and we can just use it as we need, as we want to. Okay, That was it from my side. I think I was the first who actually made the time cut, so yes. Thank you so much for your attention.